Hello student, in this video we are going to solve numerical how to find power dissipation through 2-volt battery. Always remember, before solving numerical, observe circuit. For above circuit, my first observation is circuit is DC circuit because V1 5 volt, V2 2 volt and V3 1 volt voltage sources are connected and all are DC voltage source. Second observation is it is having two loops, and third observation is all sources are voltage source. There no current source is present in circuit. Then summarize which theorem or law we can be used to find power dissipation through 2-volt battery. We are using here 2 loop current. Direction is shown in circuit. In this numerical, simply using mesh analysis or writing loop equation, we can find the answer. We know that summation of voltages existing in loop is equal to 0. For mesh analysis, consider only voltage source and redraw the circuit. So now I am having 2 loop current I1 and I2. When current is entering to any device, the polarity is positive, and when it is leaving to that component, the polarity is negative. So that's why R1 polarity first positive, then negative, then R3 positive, negative. For I2 loop current, again note down the polarity. When the current is entering in R3, it is a positive, then negative. For R2, it is a positive, negative. The loop current we are considering is in a clockwise direction. For voltage source, we can't change the polarity because it is a source. Now start to write loop equation for loop A, B, C, D and A. I am starting from point A. R1 into I1 because R1 resistor is having only current I1 flowing from it, plus R3. Now observe in R3 two loop currents are flowing and both are in opposite direction. That's why I1 minus I2, plus for first loop the two voltage sources are present, V2 and V1 is equal to 0. Now put the values for resistance and voltage. R1 is a 3 ohm, R3 is a 1 ohm. We don't know the values of I1 and I2. Then V1 is 5 volt and V2 is 2 volt. Observe the I1 is flowing from V2 battery negative terminal to positive terminal. Similarly for V1 negative terminal to positive terminal. That's why the polarity of both the voltages is minus because current flowing from negative terminal to positive, and here for R1 current flowing from positive to negative. That's why it is a positive. Simplify this equation. 3I1 plus 1 I1 minus I2 is equal to 7, or 4I1 minus I2 is equal to 7. This is my first equation. For second loop equation, now we are considering the larger loop A, B, C, D and A. For this loop, again we are having two loop current I1 and I2. So again I am going to write the loop equation starting from point A. R1 into I1, R2 into I2 plus V3. Now observe here current flowing from V3 positive terminal to negative terminal plus V1. Now here V1 negative terminal to positive terminal. That's why V3 is a plus and V1 is minus. Putting the values of R1 3 ohm, R2 4, V3 1 volt, V1 minus 5 volt. I am getting the second equation 3I1 plus 4I2 is equal to 4. Now solve equation first and second. First equation is 4i1 minus i2 is equal to 7 and second equation is 3i1 plus 4i2 is equal to 4. If you don't know how to solve simultaneous equation, please write a comment. So my next video is on how to solve simultaneous equation. By solving these two equations, I1 is equal to 1.684 ampere and I2 is equal to 0.263 ampere. Our main question is find power dissipated by the 2-volt battery. We know that the formula for power dissipation is voltage into current or I square R. Here the current flowing from the battery is I1 and I2, but both are in opposite direction. I am taking I1 is a reference current, that's why I am writing I1 minus I2. And voltage is nothing but the voltage across the component where we want to find the power dissipation. So voltage here is a 2 volt. By putting the values of I1, I2 and V, I1 is a 1.684 ampere, then I2 is a 0.263 milliampere multiplied by 2. Answer is 2.842 watts. This is my power dissipation by the battery 2 volt. Whenever we solve any numerical, we want to cross-check our answer. To cross-check the answer for electrical numerical, so many simulators are present. I am using multisim. In multisim, the circuit is connected and by using DMM1 and DMM2, we are finding the loop current. So, DMM display is showing I1 1.684 ampere and I2 0.263 ampere or here 263.158 milliampere. That means our answers are matched and the numerical is correct. If you have any doubt, then please write a comment and thanks for watching my video.